Three. Assalamualaikum and greetings to Dr. Karani and everyone. Today we would like to do our group project presentation for subject SSE 4355 Real-Time Software Engineering. So first thing that we need to do is I want to introduce our team members for this project. And the first one is Noraein Sabtu. And the second one is me, Fatin Nabilla binti Muhamad Zaini. The third one is Muhammad Haris bin Harun. And the fourth one is Jevanraj, anak lelaki Ramakreshnan. So next. The first thing that we want to present is about the software requirement specification, which is SRS. Okay, this is the system overview. Actually, the real-time system that we developed is Igor Smart Voice Assistant System, or it is also known as ISVA. It is a system that basically assists users to perform search and give answers to the user's question. And once the user has started the microphone and proceeded to ask a question, ISVA will display the question in text form and complete the action of the asked question. Okay, next. Okay, this is the purpose of ISVA. As I mentioned earlier, this is like some kind of voice assisting system that the first thing that the purpose is to start microphone. ISVA will allow the user to start the microphone. Once the user has started the microphone, they can proceed and ask questions and perform searches and more. And the second one is to display text. Once the user has come up with the question, the audio will be translated into a text version and the user can see it on the screen, and so that it is easier to see that kind of interaction between the user and also the ISVA system. And the next one is speak. ISVA will answer the user's question in speak form instead of answering in only the text base. ISVA assists the user by using a voice assistant, which is very efficient and is very helpful. And the last one is stop microphone. The ISVA will stop the operation and system when the user says goodbye, where it indicates that the user is done using the system and would like the system to stop its operation. If the user wants to continue using the ISVA, they can just continue to use without saying the goodbye. Next. Okay, this is the ISVA interface requirements. As you can see, this is the user, and the next one is ISVA next to it. And the interface type is person. Description is this actor is a person who used the ISVA to perform several actions by just talking. And the association is the actor communicates with Igor by starting the microphone to speak, and the text will be displayed to indicate the instructions. Tasks will be performed and stops the microphone after finish. Next. Okay, this is the capability requirements of the ISVA. As you can see, there are a few main functionalities such as start microphone, display text, speak, and also stop microphone. And all of this will be used by the user in the ISVA system. Next. Okay, this is the use case. The first one is start microphone, which is this use case is initiated by the user. It provides the capability for the user to start the microphone and to speak, and they can start using this ISVA system by just speaking. And the speech recognizer will also start. So once the user speaks, the system will perform tasks according to the user's command. And after the post condition, the ISVA is initialized. The next one is speak. This user is initiated by the user. It provides the capability for the user to speak in order to give commands. And it just that what I mentioned before, the first thing is the microphone need to start, then the user speaks to ISVA, and the spoken text will be displayed, and it will reply to the user's question and will perform the task. Next. And this is the display text. So once the user talk to the ISVA, and the text of the interaction will be displayed on the terminals so that they can keep track what are going on the process of interactions between the user and also the ISVA. So it will make it easier for the user to see what kind of thing that they are talking with this ISVA system. Next. And the last one is stop microphone. So once the user already finished using the ISVA, he or she can just say goodbye to the microphone. So the ISVA itself will shut down the system and will stop working. Next. Okay, this is the main class diagram. I will pass to Ain.
So right now I'm going to explain about the main class diagram. As you can see in the, we are actually using the Python language. So in the main Python language, there's a few things that you can see which is the get record audio, get speak, get respond, and also get translate, where there are a few functionalities as Fatin already mentioned just now, which are the record audio, speak, respond, and also translate. The first functionality, the record audio, will ask the user to start the microphone and also get the audio. And once the Igor already get the audio, the ISVA, it will convert the audio to string, and also lastly, it will print the string. For the second functionality, for the speak functionality, it will get the string just now and also convert the string to speech, save the audio, play the speech back again, and also print the string into the user's terminal. And lastly is to remove the audio that they already saved just now. The next one is respond, where the user will, where the ISVA will get the greetings and also get the name, search YouTube, Google, price. They also will convert the strings to speech, save audio, play speech, print string, and also lastly is to remove the audio. And lastly is the functionality for translate, where it will get the audio and also convert the audio to string. And lastly is to print the string. This is basically the main class diagram for the ISVA system. So this is basically just the sequence diagram to show how the sequence that's going to work in the ISVA system. So for example, for the record audio, user will say hello to activate the microphone. It will then send the command. And once the user sent the command, the control will verify the command. So if the command is actually accepted by ISVA, it will convert the audio to text, and it will save the text into the string and return the converted text and print the text into the terminal. So if the command is not accepted, ISVA will respond with "I did not get that," and it will also print it in the terminal. This is basically the sequence diagram for speak functionality. So the first thing that the ISVA will do is to retrieve the saved string just now, and it will convert the string to speech and save as MP3 files and send the MP3 files to be played. So once it is sent, it will play the MP3 file in the speech form to the user, and it will also return the saved string and also print the text on the terminal. So next, it will convert the audio to text and return the converted text and print the converted text on terminal. And lastly, it will command to remove the MP3 file that they have just created just now. So the MP3 file will be removed. The next one is respond, where the user, the ISVA, the ISVA will return the saved string. And if the response is valid, they will search for the valid answer in the ISVA, and once they have found the valid answer, they will save the response in string and return the response and print the text on terminal. And vice versa, if the response is not valid, they'll save the response, return the response, print the text on terminal. In this case, it will print something like "I did not get that" and stuff like that. And lastly is translate, where ISVA will retrieve the saved audio and convert the audio into text. And once it has been converted, it will return the converted text into the translate control. And lastly, will print the text on the terminal. So right now, my friend will explain about the software design documents.
Given your microphone.
Okay. Now everyone, we are going to look at software design documents. Next. Okay, the CSCI external interface diagram consists of user interface, subsystem speech input-output, subsystem ISVA software, subsystem speech recognition, and database. The list of CSCs in CSCI ISVA is number one is record audio, number two is speak, number three is respond, and number four is translate. So the components of the CSCs are record audio, speak, respond, and translate. The ISVA main program is record audio, translate, speak, respond. Relationship between CSCs is record audio, translate, and another component is speak. Going to respond, translate also. The ISVA system will respond, and the last one is API. Okay, now we are going to see at the CSCs of states and modes. The first one is idle. The system is under idle mode when the system is turned on. Then the second one is recognizing. The state is receiving command, display command. The command is the speech given by the user. So for the receive command, the system capture the user's speech. For display command, the system will display command in the system after recognizing the speech of the user. The third one is busy. This is where the system converting the audio. So the system will convert the audio to text. The second one is matching audio. The system will matching the audio with reference speech patterns. And the third one is voice response. The system respond to the user's command with the answer. And the last one is display response. The system will display response in the system screen. That means the user interface. So this is the detailed design of the system. The first one is CSU record audio. The CSU is the microphone. Class type is entity class. Responsibility, this class responsible to give updated info according to the microphone state. So the attributes is status, whether it is turned on or not. The method is get status and record audio. The second one is converting to string. Class type is entity class. Responsibility, this class responsible to convert receive audio to string, so the system can recognize the speech. The attribute is a string because the system will recognize the words or the speech in text form. And the method is convert audio to string, and another method is print string. So the second requirement is speak. The CSU convert to speech. Class type is entity class. Responsibility, this class responsible to convert string to audio. Okay, the method is get string and convert string to speech. And the next is CSU play speech. Class type is entity class. Responsibility, this class responsible to play speech after converted from string. The method is get speech. CSU print string. The class type is entity class. This class is responsible to display the sentences from speech, and the method is get string. So the next one my friend will explain.
Okay, so for the next CSC, which is the response, the CSU input is the class type is entity class, which is have the responsibility to respond to give the get input from the user when the user give input such as a greeting, name, search, and price. And then you have the method is there, such as get greeting, get name, get search, and get price. So the next one is CSU play response, which is the class is entity class. So this class is responsible to play the response speech after convert it from the string. So the method in this class is get speech. So next, for the CSU speech. So the CSU is inside there is speech, which is responsible to give speech pattern or template already stored in the data. So the method in this class is get audio. So CSS translate is also speech. The responsible is to get the audio from the user and convert the audio to the string. So let's move on to the CSCI data, which is the CSCI data is the global data element within the CSCI ISVA. So this element has been classified into two element internal, into data element internal and also data element external. In this case, the data element external is not applicable. So this is the data element internal to the CSCI ISVA. The first one is the audio, which is the CSU identifier is speech. The next one is voice data from the signal, word from the print string, and last one is microphone state from the CSU microphone. So for the CSCI data file, this section has been classified into three data files that will which is short speech, medium speech, and long speech. So this file consists the word, the total word, and the total of time taken to generate the response to the user. So for the appendix for this SDD, as we can see the activity diagram, which is the start microphone, and then go to the take command from the user, display command that has been input from the user. Then the system will check if the command is valid or not. If not, it will send the error message. If yes, it will perform action by give the voice response. And then when the user say goodbye, it will stop the microphone. So this sequence diagram already stated by my friend. So you can skip this. So that's all from us.
So basically right now we are going to demo the ISVA system. So I'm going to show the video.
Hello. Hey, how can I help you? Can you tell me your name? My name is Igor. What's your name? My name is Alice. Okay, I will remember that, Alice. How are you doing? I'm very well. Thanks for asking, Alice. Can I know what time is it? 11:49. Search for One Direction on YouTube. Here is what I found for One Direction on YouTube. Search for Proton X50. Here is what I found for Proton X50 on Google. Goodbye. Going offline.
So basically that is the demo for the ISVA system. So I think that is all from our group. So thank you.
Thank you.
Bye.